Okay, so Leetcode practice time. Task scheduler. Two goals. First of all, it is to find a solution for this specific problem, and the other one is to see how to behave during an interview given a specific question. So, the first of all, it is to uh, clarify the question and understand the question and think about some edge cases. So let's first take a look at this question. So given a characters array tasks representing the tasks a CPU needs to do, where each letter represents a different task. Tasks could be done in any order. Each task is done in 1 unit of time. For each unit of time, the CPU could complete either one task or just be idle. Okay, so however, there is a non-negative integer n that represents the cooldown period between two same tasks. So the same letter in the array. Okay, so that is there must be at least n units of time between any two same tasks. Okay, and return the least number of units of time that the CPU will take to finish all the given tasks. Alright, so let's use an example to understand what it is. So in this example, we have 3A and 3B. So task A and task B each will take 3 units of times. And we have N as 2, which means between the same tasks, there should be at least two unit of times in between the same tasks. So output is 8. Let's see why. So explanation is because the schedule of the tasks is like A, B, then idle, A, B, then idle, then A, B. So the reason is because we need to have at least two idle, not two idle, at least two units of times between the same tasks. So between the same tasks A, there are two units of times. All right, so let's take a look. Let's take a look at another one. So let's say A, B, B, B. It could be scheduled in any order essentially because n is equal to 0. Let's see this one. So task, let's say 6A, 1B, 1C, 1D, and E, F, G, n is equal to 2, and the one possible solution is ABC, ADE, AFG, A idle idle idle, A idle 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 A. Alright, so the constraint, so I think we are pretty much clear about this question. Let's see the constraints. So the tasks, the length is between 1 and 10,000, and task I is capital English letter, which means there are only 26 kinds of tasks, A to Z, and the integer n is in the range of 0 to 100. Alright, so I think it's pretty clear to me now. So the edge case, what would be the edge case? I would say, given the constraints, I don't see any special edge case at this moment. Let's step into the next part, which is about finding solution. So what will be the solution for this specific question? So based on what I can see, the total units of time is decided by the idle units of time and also the units of time that is scheduled for any tasks. And also we need to consider what would be the least amount of time to schedule all the tasks for the given constraints, which are the cooldown time between the same tasks. So I would say I would say the first step. I think this is a greedy. We can use some greedy algorithm to solve this problem. So first of all, we find given all the tasks, we find the task that takes most of the time. So let me give an example. Let's say if we have the tasks like A, and B, B, C, C, and let's say the n is equal to let's say equals to 2. So first of all, we need to make sure that we have already scheduled all the A's, because A has the most. Task A takes the most amount of unit of times. So let's say we have a and we have some placeholder for some other task we could potentially schedule in between A's. So currently it will be something like A / which represent the units of time that we may potentially need to fill in, the potential tasks we may potentially need to fill in, like here. The slash means some units of times, either idle or we can fill some potential tasks. And then we can fill in the tasks for those dashes. So let's see, we can fill in B here, and we can fill in B here. In this way, we can make sure that for both task A and task B, there are no less than 2 units of times in between. And then we can schedule C and schedule C. So I would say the least amount of times to schedule all the tasks, it is mainly decided by the task that takes most amount of unit of times, which means the most frequent tasks. And also let's take take a look at another example. Let's say if I have A, and let's say we have B, C, D, E, and N set as 2, then we would have, first of all, we have A / A dash, and then A, and we can schedule B here, schedule a C here, schedule a D here, and schedule E here. So something similar like this. And let's take a look at some other task cases which could potentially break this. So let's say if we have A and BB, and N is equal to 2, then first of all we could have A dash A dash A, and we further schedule the B, inserts the B here. So I think this is not the, the algorithm still works. Like first of all, we schedule all the A's and put the dashes in between, and then we put the other tasks in between, like we fill in the dash with the tasks. I would say this should work for all the cases currently based on what I can see. I don't see any reason the algorithm won't work for any task cases. Let's see. Yeah, I think this should work actually. Yes. So, alright, so let's give it a shot. I would say the solution for this one, we need to do at least one pass for the input array. It's going to be O of n to find the most frequent task. Okay, so I would say the first step, we are going to have a hash map which record the task and the corresponding units of times it is going to take. And then we are going to find we find the most frequent task there, and at the same time, okay, so let's see, suppose we have another task case. Let's say we have A and then B and N is equal to 2. What would happen? So if we have A dash dash, A dash dash, and A dash dash, not A dash dash. So we fill B here, we fill B here, and we fill B here. Okay, so I think this one, it is a little bit it's a little bit special because we have another B at the end. So I think alright, so I think it should still work to my best understanding. So let's see. Okay, so first of all, we would find, so the algorithm, I would say it works like this. So first of all, we find the task that takes most amount of unit of times. So this one, there could be more than one task that takes the most amount of time. For example, the input case in line 18, 3A and 3B, there are two tasks that needs 3 units of times to finish. And then let's say we have M tasks that takes the most amount of times. Then after we find this, we can further schedule the task that takes the most amount of time, putting the dashes in between, and to be further used to insert other tasks. So first step, we find M tasks that takes most amount of times. Let's say max time. We represent the most amount of time as max time. In this example, on line 18, the max time is going to be 3. Then we could do it mathematically. So it would be something like, in my opinion, it could be M minus 1 times max time. So M minus 1 max time represents, for example, in the example in line 18, it represents the AB dash and AB dash. Actually, it means A dash dash. Remember the first step, we schedule the dashes to be inserted for tasks, and so this one represents here, like all the things between the last A, and then we need to schedule the rest part, which is the AB part, which is this one. It should be something like plus M, because there are M tasks that takes max time units of times to be finished. I think this would be the final solution, but let's see if there is anything that potentially could break it. Alright, so let's say if we have another input case, let's say n is equal to 1, we put a dash a dash a, and actually we need more than this, because we could put b here, c here, but we need more than what is represented by this formula. So we could put the D here and the E here. So in this case, I would say it is the maximum between the formula we gave before and also the number of tasks. The number of task time units. Alright, so I think it should work for the solution should work, and essentially it is a linear solution, I would say, linear to the length of the task array. So the next part is about coding. So coding, we care about the code correctness and the code readability. So let's do some solid code to turn the idea into solid code. So first of all, we need to go through the task array to keep record of the unit of times. So so go through this input array. So tasks, we define a map, character, key as character, and value as integer, which is task time map as new hash map. So if task time map, if the task time map doesn't contain key of task, then would put task time dot map task map dot put the task and 0, and we need to say task time map dot put task map time dot get task plus 1. Okay, so this is a value actually, and it should be something like this. And then after we have the task and the unit of time map, then we need to find what is the maximum thing. So actually we can find it within this for loop. Max unit time, let's say set as 0. Okay. So this one should be unit time. Unit time, let's say this one is here. Alright. And we can further just say unit time here. Alright, so if so max unit time is equal to max max unit time, and then unit time. Alright, so now we have the task and the unit time map, and also we also have the maximum unit of time for a task. And now what we do is we find how many tasks that takes max unit of times to be finished. So for let's say it's car, it's task in the keys task time map dot key set. So if so let's say num task with max unit time 0. Okay, so if the task takes that amount of time. Okay, so if task time map dot get task is equal to max unit time, then we plus this one. Okay, so now we already figure out how many tasks that have that takes max unit of times to be finished, And then I think we pretty much find everything, and we can step into this formula calculation. So we are going to return mass dot which is the maximum thing. Alright, so it is a maximum. Yeah, it is a maximum actually. So it is tasks.length and m-1 is num tasks with max unit times minus 1 times max unit time plus num tasks with max unit times. Alright, so I think now we are pretty much code complete. The next step is for us to do some testing. So during the we have already gone through this code when we do coding, a little bit explanation, but we still need to go through some example to explain how it works. So let's say we take one example. Let's say we have A, B, 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 and C, C, D, E, and let's say n set as 2. So now, the first of all, we need to compute the task map and also max unit time. So initialize as a something empty, and also this one set as 0, and we iterate through the tasks. And first of all, we update A1, and then A2. So max time as 2, A3, max time as 3, and then we update B1, B2, B3 when we try to do one pass when we try to do one pass iterating through this input array. And let's say and then we would have B2 C2 and D value as 1, E and value as 1. Alright, so now we have the task time map as A3, B3, C2, D1, E1, max unit time as 3. And then we iterate through this task time map to see how many number of tasks that takes max unit time to be finished. And as we go through, we are going to finally set num tasks with max unit time as 2. Okay, and then finally, what we will return, so the mass dot max the length is 6, 7, 8, 9, 10. Okay, it's maximum of 10, and max num tasks, it is 2 minus 1 times max unit time is 3 plus max unit time num task with max unit time is 2. Alright, so we are going to return maximum among the two numbers is gonna be 10. Alright, so how this is scheduled, let's see. If it is A dash dash, as I said, A dash dash A, then we try to fill in the dash with 0 tasks. Let's say we fill B here, we fill B here, and we fill B here, and then C, and then C here, and we could fill the D here, and we could fill the E here. Alright, so actually 10 is the right answer. So I would say this looks pretty good to me. Let's give it a shot by running this piece of code. Okay, so unit of time. Okay, so some typo here. Let's give it another try. So task. Okay, so another typo here. Task time map. Okay, it's a wrong answer, and why it's a wrong answer. Okay, so we have 3A and 3B. If we need to put so if it's 3A and 3B, first of all, you have a dash dash a dash dash a. Okay, and then we have the b here, we have the b here, and we have the b here. Why it could be wrong? So in this case, we have the map. Okay, so we have the map and max unit time defined as a3 and b3, and the max unit of time takes is 3, and number of tasks with max unit time as 2. Alright, so what we do, okay, so actually it is alright, so let's see. So there is something wrong with the formula actually, based on what I can see. So it's not the max time. It's not the max time actually. It should be n plus so it should be n plus 1 here. So okay, so let me tell you the reason. So why it is n plus 1 here. So actually this how we decide how many dashes to put in between the same task. It's decided by the cooldown period. So in this one we form a dash dash and then another a. We put 2 dashes in between the a. It is because n is equal to 2. We need to maintain at least 2 cooldown period in between the same task. So the formula actually it should be m minus 1 times the cooldown period plus 1, and then plus in m. So now after we run this piece of code, let's give it a try. I think, still a wrong answer. Let's see why. So if we have max task with max unit time as 3, and then max tasks with max unit time as 2, then it is 2. Okay, so this one, okay, so I got confused. I think this should be max time minus 1 multiply n plus 1. So this should be max unit time. Alright, so let's see. Let me explain. So we clarify the confusion, which was my fault. Like what is how long it is for each repeat. Like for this specific slot, it is decided by the cooldown period, and then how many how many times we need to repeat those slots. It is decided by the unit of times for the longest the task that has the longest unit, that takes the longest unit of times to be finished. So so this one it is 3 because a takes 3 units of times to be finished. So let's give it another shot. I think this time it should be right. Okay, then let's submit it and see how it works. Okay, so now we are already good enough for this one. So I made some mistake when trying to form this formula. I think I was confused by myself actually, but it's good that we finally got it. So regarding the task case, I would say we set up something. So one thing I can think about is we take the task dot length instead of the number from the formula. So I would say something like the task case in line 33. And the other one is we actually use the number from this formula, which would be something like the test case in line 41. So I would say if we come up with those test cases, we should be good regarding the test coverage. So that's it for this coding question. So thanks for watching this video. I hope you find it a little bit helpful. It's pretty normal behavior during a coding interview if you get confused sometimes. And this time I was confused as well. Sorry if it takes a little bit time for you to watch this video. I hope you feel it a little bit helpful, and if you feel like it, please give me a thumb up, and I'll see you next time.